All right. Good morning, folks. Today is Saturday. It's about 5 a.m. Eastern. Um, Hope you all had a good week so far. I know I did. I had off all week. Unfortunately, I have to go back to work next week. So, yeah. But, it's part of it. And I make good money and work with a bunch of good folks. So, uh, we all rather sit at home, drink coffee, whatever, but we still got to earn a living. So, um, anyway. This is um, a different look at the tropical Atlantic. It's called Sandwich. It has like IR with visual overlaid visual satellite, and off the west eastern coast of Africa, you can see the visual satellite coming into view here, first light. And here's Gabrielle. I forgot to bring out my Epic pen. Here we go. All right, here we go. It's gonna work here. There's Gabrielle. Still a little bit of shear on it, and most of the winds are on this side of it right now, but it's much more impressive than it was 2 days ago. Likely to move east of Bermuda, at least the center of it, probably somewhere in here. But the track has been shifted further south, likely delaying extratropical transition in the open Atlantic as it curves back to the east. Uh, so that's Gabrielle from a wide angle, right? And let's look at a closer up view of it. There's a Geo-Color look. This is still not getting first light images. Won't for a couple hours yet here. We go to Sandwich like we looked at previously with the wide view here. Looks very impressive. But one of the things you can look at with shear is quite a sharp line here on the western side, which indicates not a lot of outflow going this way right now. More going like this. But overall, the moisture surrounding it is much better. If we look at the IR loop for the upper levels, a lot of moisture here. The greens, deep greens, equals a lot of moisture in the upper atmosphere, especially rising motion. Mid levels, looking much better surrounding it, even though there's some dry air to the north and to its southwest, northwest, northeast. But if it can maintain convection, it as a result of its convection and uh, the continuous cycle of rainfall, and will moisten up the atmosphere surrounding it. And if it can maintain itself that way, it will help some to maintain its intensity. Uh, Low level water vapor, quite dry surrounding it at the lower levels, but it looks like it's got a good moisture pocket with it. So, and the National Hurricane Center's indicated that it doesn't look like it has any stronger winds than it did before, even though it looks more impressive because shear in the circulation is kind of on the western edge, low level circulation on the western edge here of the convection. So, one way to look at this is the microwave CMIS tropical cyclone site for Gabrielle. On the left is Morphed Integrated Microwave Imagery, which a very valuable tool to analyze the structure of a tropical cyclone. And the higher reds here, the deeper reds, indicate more convection, and structurally shows what the most convection is. You see where the brightness temperatures are the highest on the western portion, this eastern portion of circulation, excuse me, towards the end of this run here, 20 September, right? It's going to get into, let's see. Yeah, this is, there we go. That's what, towards the end there, you see where the deepest reds are on the eastern side. So on this other pane over here, this is a more interactive look at this, showing all the model tracks and intensity forecast, forecast BCAT2 when it moves east of Bermuda. All right, so we take these off and we can show the satellite winds. And the satellite winds estimated the different wind speeds based on these colors down here. Some 34 to 49 knots estimated, which is about equal to the current intensity. You see the strongest winds are still on the eastern side. Sorry, I keep getting that screwed up. So one of the things that still we talked about was the shear on the system. You see there's still some shear coming from the some deep lever shear on top of it, about 10 knots. You can see it's forecast to move in a more favorable area of shear, which will likely lead to some faster intensification probabilities, the greens, and almost no shear at all shortly. 5-10 knots maybe. Mid-level shear, still some mid-level shear, 5 knots or so from the north. We'll see what this anticyclone is when it gets up to this area, but overall, National Hurricane Center thinks the shear is going to decrease, and we see surface temps being warm enough and even get even warmer up here in as it moves to the northwest, west northwest. That's not the sea surface temps are not a problem for it to develop if all other things being equal. As far as convergence at the surface, if we go back to take the shear out, convergence is right over, at the surface is favorable. Okay, divergence aloft, lots of divergence here, which is excellent for this system to develop more. And vorticity, looks like the vorticity maximum, like the National Hurricane Area said, is a little bit removed from where the cyclone is right now to the east here. You can see the oranges here. So once the shear relaxes, the vorticity center at the surface should become more aligned with the upper levels and likely to intensify. Drier air, we looked at that earlier. There's drier air to its north. but overall the dry air is a lot less pronounced than it was even 24 hours ago. What do the hurricane models think of the system, right? Back to the satellite loop real quick. Well, let's back up. Let's look at the National Hurricane Center outlook for this. Um, Interesting. This is not. Let's see if this is updated. There we go. Tropical force, storm force wind probabilities still within the 20-30% range. 40% possibly impacted Bermuda uh, as it makes its closest pass, and then recurving out to sea, out to the. It's always at sea. I know people make a big deal about that, but recurving. How about that? This is the probability of getting 58-mile-per-hour winds. The highest probabilities in the red, of course, in the center. And it's not out of the realm possibility that Bermuda might get these, but it really depends on the structure of the system as it passes closest past to Bermuda here. And hurricane force winds aren't likely to impact Bermuda unless this thing really takes a big jog to the west. And this is the key messages. We kind of talked about this. Supposed to pass east of Bermuda Sunday night into Monday. Some wind and impacts, rainfall impacts are possible. I think the biggest impacts, honestly, are going to be rip currents and swells and Bermuda as it moves towards it. Usually, when systems move to the east, the left side of the system, most times, is less likely to have higher winds than the eastern side. So that's just the way the systems work. And with the unless the wind flow, unless it was moving in a weird direction, like this way or something like this, which is not likely in this case, then you might have some different impacts. But anyway, on the next thing, there's a rip current risk. Obviously, we don't show Bermuda here. It's like a little dot out here, but it doesn't have rip current impacts for it. But you can assume that rip current impacts are going to be high. And on the East Coast, obviously, the swells are going to start reaching the East Coast as well in the coming days. This is the latest wind field. You can see what we're talking about here. As of 5 a.m., almost all the tropical storm force winds are on the eastern side right now. And this is the latest interactive cone. We kind of looked this already, but the cone is of course gets wider as you move further away in time just because of uncertainty. So it's possible the storm could end up being here, the center of it, or it could end up being here. And this is just where the mean center average of the track guidance is expecting it right now. So if it ends up being here a little further east, of course Bermuda would be impacted more. So just have to keep an eye on it. Now moving on to the hurricane models. I wanted to show this is one of the hurricane models, HWRF. This shows a structure, infrared satellite structure of the system um, modeled by this model. Okay, so we looked at infrared over here. Let's look at this real quick. Okay, so this is an infrared satellite. You see the deep convection, that's really deep convection right there, but the clean um, uh, Well, anyway, you get the idea here. So, likely to become a hurricane. You can see the eye there. This is around midnight Monday, and there's Bermuda. Okay, right there. Okay, so move through it for one time here. This model wants to get this sheared out pretty quickly once it passes to the northeast of Bermuda. You can see almost all the convection is sheared off here. Okay, this is the HAFS-B parent, which is a parent model to the HAFS-B, right? Just gives a better zoomed out view. That's why I use this, and showing where things the system will be around, let's see, 6 on Monday, which is about midnight, just to the southeast of Bermuda, and impacts from winds will likely be, according to this model, not very impactful. There's a HAFS-B representation of the satellite presentation, very similar to the little more high resolution look here, similar to the HWRF hurricane model. And these models are designed specifically to forecast hurricane intensities, tracks, stuff like, and different parameters. One thing I want you to note here, you see this system down here in the Caribbean. This hurricane model is picking this up because it's within its domain as a hurricane. Looks like with an eye there on the 23rd of September. I don't know if that's really going to happen or not, but that's likely related possibly to the tropical wave moving to the west here. We'll just have to see how that plays out. And we talk about winds and waves. This is a GFS representation of what the combined waves and swells will look like in this impact on Bermuda. Because of its relatively small size, not as many impacts as if it was larger, but you see the swells making it all the way to the east coast. And Bermuda is the biggest impacts, of course. And that system here that it wants to do something with. So, moving on to the models, the EPS, cyclone development, right? This is the European Ensemble modeled output as far as probabilities of a hurricane developing. Tropical depression, storm, hurricane. The brighter oranges, of course, close to 100%, brighter reds. So, the highest probabilities of hurricane, according to this, still 30-40%. But I would argue that it's pretty likely to be a hurricane. So I'm not don't like take this as gospel. I just want to show this to you. And then we have this other system. When we get further out here, and here, tropical storm. It doesn't even show a hurricane developing here, but tropical depression probabilities in the north of the Caribbean. So there is some support for this. And then into the main development region, tropical storm, and into the Gulf of Mexico. So lastly, as far as the systems that are further out, right, on time here, let's go back. This system here is what we were just talking about with after Gabrielle gets out of the way. Um, the National Hurricane Center keeps pushing the 7-day outlook out 20%, and they moved it further to the northwest here, development area. Previously, it was further south. Uh, but this is what I'm going to talk about next. And what I'm going to show you is the Google DeepMind um, output here in a couple different ways. And move this through time. You see Gabrielle up here, this wave here. And the Google DeepMind, once it's available, tropical storm, with the next graph off the north of the Caribbean islands and off the southeast coast. And then it loses it because the model doesn't go that far out. But that's that. Another good way to look at is this Weather Nerds website. This is the Google DeepMind FE3. This is Gabrielle out here. And this is the Weather Nerds website, which is free to use, and it's really a good tool. All the L's indicate one model, run ensembles, and the pressures with them, and with the numbers there. Move this through time here. You see they all want to loop it back out to the Northern Atlantic. Um, and these different colors are here, just anomalies, sea surface time anomalies, all above normal pretty much, in the reds there. So Gabriel moves out. You can see that low picking up this low, this low here, and another one here. Quite a lot of support for this in this area, and in this area too. Then this is 7 days from now. And this model has been very consistent with showing two distinct systems here, developing, and in different runs have shown different solutions here. So, I think there's quite a bit of support for both of these to develop in the longer term. If we look at the Google DeepMind again, this is a different, I'm not really sure what the difference is here, but it's probably a different backend model engine. Shows pretty much the same solution except less members to the, it's a more subtly solution here for this other law of the Caribbean and the Gulf of Mexico. Don't be alarmed by this. This is just information. This is 1 October, which is 11 days from now. However, I would say there's been quite a bit of consistency with these models. And it remains to be seen how these perform, but overall, I think the AI models have done well, so that's why I'm showing this. Just for reference here, this is the European Ensemble. This is the European Ensemble members for Gabrielle. You see there's 51 of those. And this is this tropical wave that we were just talking about. There's some support for the European here with it developing and curving up. But when we get this far out, there's a lot more disparity, and the lows are everywhere, so it's really hard to tell what the heck is going on here. But we have plenty of time to watch this and look for trends here. But overall, support is gaining for this next system to develop, and maybe one in the Gulf of Mexico, Caribbean. Why did I do this? Okay. Anyway, what is going on here? Sorry, guys. All right. um, this is Gabrielle. This is the GFS Ensemble, which is 31 members. It depends on the run here. Some of them, one model has 21, and some people say it has 31. The reading I've done, there's 31 ensemble members. So GFS is the farthest west, with I would say in the European or further west, with Gabrielle, but still all members, almost all of them, move them east of Bermuda. And the GFS has a lot more support for this low, rather weak, and then model just guidance is all over the place. It's really even hard to tell this far out what's really happening here. You see the lows all over the place. But, you know, I really think, guys, that the Google DeepMind and the other AI models are really onto something possibly developing in the Caribbean and the Gulf of Mexico, so we just need to keep an eye on it. Um, that's all I got for the tropics, guys. And next thing I'm going to go over is the continental U.S. forecast and the local forecast from Warner Robins.